Hello and welcome to Science Fair Workshop Experimental Design. Here I'll be walking you through the Science Fair requirements as well as helping you get a start on your experiment, which I know you're very anxious to get started on. So I'm going to talk about words like variables and trials and constants, so we're all aware of everything you need to do to set up a successful experiment. So first, let me remind you of what the Science Fair is. It's an opportunity for your child to be a scientist. So we didn't begin right off the bat their experiment. We've been doing a few other things first. So your child spent Unit 1 thinking about their project and writing up their project question. They should have typed that project question back in Unit 1. In Unit 2, they spent 6 weeks writing a research paper. Now, why did we spend so much time writing a research paper? Well, the very next step that they should have done last week is to come up with a hypothesis. A hypothesis is an educated guess. So we spend a lot of time helping your student become educated on their topic, so that way they can make an educated guess as to the outcome of their experiment. So now the step is to begin thinking about the materials and the procedure to proceed with their experiment. Now this Unit 3 is longer than usual. It's 7 weeks, but in reality it's 10 weeks because we have a 3-week winter break. So I definitely recommend your child work on their science fair project over winter break. It's a great time to get that experiment completed, so when they come back in January they're able to go right into their data and their graphs. All right, so the science fair, the student will become a scientist. They'll be coming up with a question, they'll be writing a hypothesis, and they'll be conducting an experiment and gathering data. The science fair needs to be written up first in the daily log, so they should have begun this in Unit 1. But every time that they work on their science fair project, they should be writing their rough draft in here. So beginning in Unit 1, they should have written up some questions, some ideas they had about topics, and then they would have typed their project question. So this is the rough draft. And then the typed work will go in what's called the notebook. So they're already beginning work on the notebook. The notebook is done little by little over the last few months and into January. So for example, they would have typed their project question. That'll go in here. Their review of literature will go in here. Their hypothesis will go in here. So this is the rough draft. This is the final draft. And again, if they're following the tips in the handbook, they'll be creating this as they go. And then they also do, of course, a display, which is this enlarged and made pretty. Now the display can be a traditional display or it can be a digital display, and I'll be talking more about that in the January workshop. And then lastly, of course, is the presentation where they tell their judges everything they did over the last few weeks and months. Now I mentioned the handbook, so I hope that your child has printed this or has saved it on their desktop. They're going to be using it every day they work on their science fair from now until February. This tells you exactly step by step how to do the science fair project. Do not wing it, do not make it up. You don't need to do that. Just follow what it says in here. So for example, they would have already completed tips 1, 2, and 3 in Units 1 and 2, and then now they're going on to tips 4, 5, 6, and so forth. Now when I say tips, at the top of each page is a tip. So this is on the experiment. It gives a pretty lengthy explanation of what to do. And then at the bottom it says your turn. They write in their daily log, their rough draft, and then they type it and save it for the notebook. So be sure your child is following this and doing exactly what it says. Eventually it'll tell you exactly what goes in the notebook, what goes on the display, and so forth. So it's a very helpful guide that you definitely want to have access to throughout Unit 3. All right, so let's go ahead and begin talking about the experiment and some terms that you need to know. Now in tip 2, it talked about how your science fair has to be a fair test experiment. To remind you what that means, it has to be an experiment that generates data. It cannot be a big book report. It can't be a beautiful display all about flight or all about volcanoes or all about earthquakes without actually doing an experiment. So make sure that you are conducting some sort of scientific study, some sort of experiment. It'll look different depending on what kind of subject you have. For example, if you're doing a psychology experiment, you might not be using test tubes and beakers and so forth, but you're still asking questions and you're still generating data. Also with a computer science project, it might look a little differently than this, but what I'm talking about today is the general regular experiment. So there are terms you need to know. The first term you need to know is what is an independent variable. So the independent variable is the variable you are changing. So it's what you're comparing, it's what you are studying. You only want one independent variable. You don't want a very complicated project where you're changing lots of things to figure out what happens. You want one variable you're testing, and that's called the independent variable. Then what you're measuring is called the dependent variable. So the dependent variable is what you are measuring. You need to have some sort of data generated, which means your experiment needs to use some sort of scientific equipment. So either you're recording temperature, or you're recording height, or you're recording weight, you're recording speed, you're recording rate. Somehow you need numbers generated. If you don't have numbers being generated, then you're not doing a fair test experiment. So your independent variable is what you're changing. The dependent variable is what you're measuring. Now, what you keep the same are called constants. So every science fair experiment needs something you're changing, something you are measuring, and then the rest of the variables you're keeping the same. You're not changing everything. You want to keep them as constant as possible. And then the last term you need to know is the term called trials. And what trials are is duplicating your experiment over and over. Now, why do we do trials? Why do we do the experiment more than once? Why isn't once enough? Well, let's take the example of the pharmaceutical company. Let's say a pharmaceutical company created a drug that helps headaches. And they say this will definitely cure your headache. We're absolutely sure. We've tested it on one person, and this one person's headache went away. Would you take that medication? Would you trust that that's a reliable medication? Absolutely not. Pharmaceutical companies have to go through millions of trials before they release anything to the public. So you don't have to do millions of trials. You just have to do enough trials to generate enough data that makes your test reliable. Now, how many is that? It depends on each experiment. Each experiment is unique. If it is a fairly simple to do experiment, fairly inexpensive, then we're going to expect to see more trials. If it is complicated, very costly, then we will accept less trials. Now, as for human studies, we expect 20, 50 to 100 test samples. So if you're doing a human test study, remember that we're expecting a lot more test subjects taken into account. Also remember, if you're doing a human study, you need to have a consent form for every single volunteer you have, be it adult or child. So for more about trials, you can go into the handbook. It talks quite a bit about trials. You can go onto Science Buddies. They have a section on trials. You can also email me, and I can tell you if you have enough trials or not. So another reason we do more trials is because what if you have a result that's weird? What if you're growing plants and you have a couple of plants that don't grow at all? Well, thankfully, you've been growing 10 trials, and so you can throw out those 1 or 2 plants that didn't grow because you've had enough trials to cover those discrepancies. So be sure you have enough trials where you're doing the experiment over and over again. So let's use an example so you can understand what these terms mean in a real project. So my sons were all Cub Scouts, and they did a lot of these Pinewood Derby cars. So let's say that they wanted to create an experiment based on the Pinewood Derby car. Now there's lots of variables you can change. So there could be lots of independent variables. So think about a few. I could change the wheels, I could change the shape, I could change the paint, I can change the weight, where I locate it, I can change the amount of weight, I can change the type of weight, I can change the lubricant I use on the wheels, and so forth. So you get the idea. There's a lot of things I could change to get the fastest Pinewood Derby car. Now, do I want to change all of those things? Definitely not. I only want to change one thing. The one thing I change is called the independent variable. So there's that term again. So in this example, I'm going to say that I'm changing where the weight is located. So my independent variable is going to be the location of the weight. All right. So I might have it in the front, in the middle, and in the back. Now I have to keep constant everything else, which means I need to have the same shape, the same wheels, the same lubricant, the same paint, and so forth, same track. Okay. So all those are called constants, are the variables that I'm not changing that I'm keeping the same. So in this case, my independent variable is where I'm putting the weight. Now the dependent variable, this word again, dependent variable, is what I'm measuring. So in this case, what am I measuring? Well, I'm measuring the speed, and I'll measure it in seconds. So how fast it takes to get down the ramp, I'll be taking speed with a stopwatch. So that is my dependent variable. So my independent variable is one thing I'm changing, and I'm changing the location of the weight. Everything else I'm keeping constant. And then the dependent variable is the measurement, and that is the speed. Now, what are the trials? Now, this is a rather time-consuming experiment because I have to build quite a few of these. So I'm going to say about 5 per weight is an acceptable number. So 5 cars where I change the weight to the front, 5 in the front, 5 in the middle, 5 in the back, and I erase those. That would give me enough numbers to average and to have a little more valid experiment. So I would erase this 5 times, again, with the weights in the front, 5 times with the weight in the middle, 5 times with the weight in the back, keeping everything else constant, and then that would give me enough data to make a conclusion. All right. So we've talked about what a science fair is, what the requirements are. I've told you to definitely follow the handbook and do exactly what it says. And when it says your turn, be sure that you're writing that in your daily log and then typing it and saving it on your desktop. That'll save you a lot of time when it comes to putting the notebook together because you've basically done almost all of it if you're following it step by step. You're going to have a daily log, a notebook, and a display due at your presentation in February. You know that your experiment needs to be a fair test experiment. You need to have data generated. You know now that you need to only change one thing, that's called the independent variable. And what you're measuring is the dependent variable. You know that you have to keep everything else the same. Those are called constants. And then you know you need to do it over and over and over again. The more the better, and those are called trials. You also understand that you should probably work over winter break, especially if you have a more time-consuming project. And then when you come back in January, you'll go right into the data and organizing it in a computer-generated graph or chart. So thank you for tuning in, and good luck. And definitely email me if you have any questions. Over winter break, I'll be checking my email. So contact me if you have any questions about your experimental design, and good luck.